This is question 8 of June 2015 S1 Edexcel International paper. It is the last question on the paper. It's a histogram question, fairly standard question part A. You just need to know the answer. It's because time or the data is continuous. We don't do histograms unless the data is continuous. Okay, so that's part A. Part B, the number of people that have spent 18 and 20, find the number of people that have spent between 18 and 25. Well, obviously 18 and 25 are along there, so we need to try and find what each one of these squares represents. We are told between 11 and 21 there's 40 people. So that basically means, if we look at this, we've got 8 squares here. You got the idea, I hope. There's 8 squares there. So 8 squares represents 40 people. So one square, one of these, one square represents 40 divided by 5, which is 5 people. So let's see if we can answer the question from that. It says estimate between 18 and 25. So let's rub that out again now. Well, here we've got a class width of 10 there, but more to the point, 18 is 0.3 along there. So we need to work out that area in squares, and then that's up to 25. So that's adding up on that area. Okay, well, looking at this bit here, that area is equal to 0.6 times by 4, because we've got 4 squares here, and this is 0.6 of the whole thing, so that's 0.6 times 4. This area, well, as I say, we've actually got 1, 2, 3, 4, 5 squares there, but we're not going all the way along there, so that's 0.8, because it's 0.8 out of 1, so it's 0.8 times by 5. So that's the area. So that equals to 6.4. So that's the area that we've got. If we go back to what the actual area we found, that's the cutting that off slightly there. And there, that area we found is 6.4, but each square, each one, if we call that area 1, so each square represents 5, so the frequency here is 5 times 6.4, which is 32. Okay, right, so now we've got another interpolation question. It's used the word estimate here. Don't always assume that we're going to be interpolating, that it's going to tell us to interpolate. But it's definitely interpolation here. Right, so now we've got 200 people in total, so the median, if we half that number, will be the 200 over 2, which is the 100th data value, which is what we're estimating. So we'll need to look at how many each of these groups represent. Now here we've got 1, 2, 3, 4, 5, 6, 7, 8. So we've got a total frequency of 40 here. And in this one, as we've seen, we've got 1, 2, 3, 4, 5, 6. So that is 6 times 5, that's a total of 30. And here we've got 7 squares. I think, if you look carefully, I've not marked it very well, but it's 7. We can see that's 7. So that's got a frequency of 35. And between here, it's got a class width of 5. It's got an area of 8. So that means that this has got an area of 40. So here, cumulatively, let's write this in red. We've gone up to 70 there. We're already up to 105 here. So the median is in here somewhere. So that's our first thing we have to do. Okay. Right, now the next thing is what I tend to do is, let's just move this, the further questions out of the way for the moment. What I tend to do is do a little diagram. We know the median lies somewhere above 26 and below 31 because it's in this group. Now the total frequency, let's color code this, might help. The total frequency between the in that group is 35. Okay, we assume that it's evenly spread out. So if we were to ask for the 17th or 18th, we would assume it's in the middle. So we would be guessing then it would be halfway between 26 and 31. But it's not exactly in the middle. So we'll work out the number. We want the 100th, and 70 have come before, 30 from here. And 30 and 40 from here and 30 from here. 70 have come before. So we want another 30 into this group. So in other words, quite a long way towards the end. So if we were to do this without any calculation, I might guess something like 30, because it's, you know, a long way. If we assume that the numbers are evenly spread, of course we don't know, they could all be bunched around the 26 for all we know, but we assume they're evenly spread. And so if they were evenly spread, 30th would be a long way up somewhere here. Okay, but obviously I'm only using that to visualize it so we can come up with a calculation. So the median, let's go back to blue. The median is approximately 26 plus some fraction of the class width here, because we're going from the class width is 5, and the fraction involves these two numbers here. So it's 30 over 35 times 5. Apologies, I've just realised it's come out, actually the frequency in here is 36, because in fact there was one extra bit here, which was 1/5 of a square, which I didn't read properly, because the square is up there. So that it didn't, there was that extra bit on top, which makes a difference of 1, so it's actually over 36. Okay, hopefully the scanning on your exam paper will be easier to see than the screenshot I took to get this, which was harder to see. So that number comes to 30.2 to 3 significant figures. Never give fewer than 3 significant figures. So that is the median. Now, here it says the midpoint of each bar is represented by x and the corresponding frequency by f, so that sigma fx is equal to 6390. I suspect it's going on to, in a later part, to talk about the mean and standard deviation. So, well, okay, let's try and take a bit more care than I did with the frequencies before. This frequency here hopefully is a bit easier. I think it does work out bang on this time. The number of squares here is I'm just trying to 1, 2, 4, 6, 8, 9. So this number here is 45, I think. So I count again. It is difficult on this, on the screenshot I've taken. Let's try and maybe if I expand it a bit, might make it a bit easier. That's better, isn't it? You can't do this in the exam, but there we go. 1, 2, 3, 4, 5, 6, 7, 8. And you can see what I was talking about here with the extra one, which made it 36, so do take care. So that's 8 times 5, that's 40. And here we've got this 1, 2, and then we've got this, it's actually slightly short of an extra one, so it's going to be 3 times 5, which is 15, but 1 fewer than that, which is 14. And here this looks like it's actually pretty bang on. It's exactly 4 squares, so that is exactly 20. And this is 1, 2, 3, 4 exactly, so that's 20. Okay, so let's just minimize that, get that normal size again. Okay, that was better, so I've done that to start with, shouldn't I? Anyway, let's rub that out. So it's the midpoints we want. So the midpoint, we've got sigma fx is the midpoint of this, which is 11 plus 21, plus 11 plus 21 divided by 2, which is 16. So that midpoint is 16, and that's 16 times 40. Plus the midpoint of this, 26 plus 21 divided by 2, which is 23.5, and that's times 30. Okay, so we'll blow those bits out as well. The midpoint of this, 26 plus 31 divided by 2, which is 28.5, times 36, plus the midpoint of this one, 36 plus 31 divided by 5, which is 33.5, times 40. Okay, the midpoint of this one, which is 36 plus 41 divided by 2, which is equal to 38.5. We could have seen it's just 5 more than the one before, by the way, but never mind. Times by 14. Plus, this number is easy to see, that's the midpoint of between 41 and 51, which is obviously 46, times 20. And then plus the midpoint of this one, which is obviously 61, times 20. And that equals to 6390. Okay, and that's the answer to that, because the answer was given. Right, now let's just look at we're nearly there at the end of this paper. Let's look at what the question was actually asking after that. The mean and the standard deviation. So that this was the answer to D. E, the mean is equal to sigma fx over x, so that's equal to 6390, divided by the over n, or sigma f, and the total number was 200, so that's over 200. Okay, and that equals to 31.95. The standard deviation is equal to sigma fx squared divided by n, or sigma f, but we know n, so I don't want to bother writing sigma f, take away the mean squared or x bar squared, whatever in this case. So that equals to the sigma f squared is given, that's 6238430 divided by n, which is equal to 200 divided by the minus the 31.95 squared, and that equals, if we round it to three significant figures, 13.1. Okay, right, so now we're going on to talk about skewness. So skewness, this formula will always be given in the exam, you'll never be expected to remember it. It's a measure of skewness. If it comes out highly positive, like a number 1, then you know it's positive skew. If it comes out, or 2 or whatever, if it comes out negative, negative 2, say, then you know it's negative skew. If it's close to 0, 0.1, 0.2, say, then you'd say, or minus 0.1, minus 0.2, then you could say it was symmetrical. Okay. Now, the answer here says, talk about, so let's just do it. Measure skewness. So I do tend to lose my train of thought at some time. So the measure of skewness is equal to 31 minus 31.95. Take away the median, which is the 30.2 that we had before, divided by the standard deviation, which is 13.1, and that gives me an answer 0.409 as my measure of skewness. Now this is one where you shouldn't really get too worried about whether this, if I look at the original data here, I would personally say no, it is slightly skewed. Looking at it, at the graph, it looks like there's a slight positive skew in this data, if we look at it. So I would conclude that there's positive skew, but it's not particularly strong, and as I indicated, a number of 0.1 would probably indicate no skew at all, or that negligible skew. But 0.409, there is positive skew. Which leads me to part G. It says the manager supermarkets decides to model these with a normal distribution. Comment on the manager's decision, give a justification for your answer. So I would say it's not justified, not a good idea to model, or normal distribution is not a good model. Is not a good model because the data is skewed. It could be negative skewed as well, and it still wouldn't be a good, so I'll put positively in this case. In this case. Spelling it positively is positively bad, I think. Positively in this case. However, looking at the mark scheme, they did allow candidates to say that this was this was fairly symmetrical because it's close to 0. But of course, in that case, you would have to come to the conclusion that the normal distribution is a reasonable model because the data is quite symmetrical. It really depended. Two questions really, when it was marked, were taken together, depending on what it is. So If you're in a situation where you don't know which way to commit yourself, it could be, not necessarily, it could be that both answers are actually possible, and you've just got to justify it based on what you've done. Okay, so that's it. June 2015 International is now done. So for any people who are taking S1 either internationally or in the UK paper tomorrow, good luck. Bye.